Welcome to a lesson with Dr. Powell. Let's take a look at how we can work through this practice problem. So we're going to be taking the derivative of this function. This function has an exponent that's variable, as well as a base here that's variable. So how can we tackle that? We can do this in a couple different ways. The first way is going to be boxing. The second way is going to be by just logarithmic differentiation. So let's compare the two and work through them. So first, we're going to do boxing. All right, so we're going to look at the different parts of the expression that are distinct from each other. Notice we don't have boxes inside of boxes. They're kind of separate here. So here, here, and here. And we're going to treat one at a time. So we're going to pretend that everything outside of a box is constant. And we're going to add the results. And that's going to be the derivative. That's what the boxing method really gives you. Now remember, at the end of taking care of a box, though, multiply that result by the derivative of whatever the box was. Okay, so we first think of the box as being a variable, and we proceed. So if this box, cosine x, is a variable, and it's raised to a power, think of, and this is divided by a constant, that's like 1 over that constant, right? That's like 1 over x plus 1 is like a constant times cosine x, which is the variable, raised to a constant. So this constant will stay out there, 1 over x plus 1. This power comes down. X, normal power rule. Cosine of x raised to the x minus 1. Now in the end of doing this, you need to multiply by the derivative of the box. The derivative of the box, so the box is cosine x, derivative of that is negative sine x. So this is what we get by using the cosine box. Then we have to add to this what happens by using another box. Let's use this box up here, the box x. Okay, when that's up there. So if we use that box, all right, so this is like saying, again, this 1 over x plus 1 is like a constant, so we can just kind of pull that out, 1 plus x plus 1 times, and then we just have, we're going to pretend like this cosine x now is a constant raised to a variable x. Okay, so it's like we have, so let's write it here, 1 plus x times a constant raised to a variable. Okay, so we're going to pretend like this cosine x is a constant. So how do we take a derivative of something like that? That's like a to the x. What's the rule here? Derivative is ln of a times a to the x. So we use the same idea. Ln of the base. The base is cosine. So ln of cosine x times the base raised to the x, raised to the variable, which in this case is x. Then to trade off, you have to multiply by the derivative of the box. The box is x, derivative of x is just 1, so that's kind of nice. All right, so we're done with that box. We just have one more to go. Plus, and honestly, I mean, if you're fluid and familiar with this, just go quickly. I'm taking time to explain. So with the next box, we have x plus 1, but everything else on top is like a constant. So this is like you have a constant, cosine x, raised to the x, all over x plus 1, where this is just simply a constant. I mean, you could think of this, if you want, as just being cosine x raised to the x as a constant times 1 over x plus 1. That's great. And even if you want, you could think of that 1 over x plus 1 as simply being x plus 1 to the negative 1, where this guy is just a constant, and this is the variable part raised to the negative 1. That's all you're doing times that constant. So we could think of having that constant, cosine x to the x. Now remember, in this case, we're doing x plus 1 as the what's being boxed. So cosine x raised to the x here, And then the negative 1 comes out front, negative 1 times x plus 1 raised to the negative 2. And we've successfully, actually, we're done. I mean, you could probably simplify and rewrite it, but nonetheless, this is an expression which is equivalent and equal to the derivative. We just took the derivative. This whole thing is equal to y prime, and that would be acceptable as a correct solution without any simplification, at least. So, but yet this is equivalent to what you would get and do if you did something like logarithmic differentiation. Now, I explained the steps, but then again, this can go rather quickly. If you're used to thinking of everything as being constants and only one thing is the variable, it could go rather quickly in doing this, just multiplying by the derivative of whatever the box was in the end as we go. Oh, I forgot. Yes, of course. The derivative of the box. Well, what's the box here? The box is x plus 1. What's the derivative of that? It's 1. Should have multiplied that out. Always remember that. All right, so times 1, just like I had times 1 here. Derivative of the box is 1 in that particular case. Okay, so now let's take a look at what this would be with logarithmic differentiation. So what we would do is we would take the natural log of both sides. Natural log of y is equal to the natural log of this. Now, using rules of logarithms, you could think of this as being the exponent coming out front. If you just take the ln of the top, but the ln of the top, so the ln of the whole thing is the ln of the top minus the ln of the bottom because of this division here. So ln you can check, but with logarithmic properties, you get this part really looks like this. Now you just take a derivative of both sides. Now this side right here is just 1 over y, then what you multiply by the derivative of the inside, which is y prime, or dy dx, I guess, and that's equal to, you can use a product rule here. Derivative of the first part is a 1, and honestly the product rule is boxing, because you like say derivative of this part where that guy's constant, and then you add to that the derivative of this part, assuming that's constant. So it's kind of, it is boxing. Product rule is just an example of that. So you have derivative of x is 1, then you have times the natural log of cosine x using product rule plus x times the derivative of this part, which is 1 over cosine x, but then you multiply by the derivative of the inside of natural log, which is negative sine x. Okay, and then you have, and then over here in this case, derivative of that is just minus 1 over x plus 1. Derivative of the inside x plus 1 is just 1. Okay, so essentially we have y prime now, because y prime will be equal to all of this multiplied by that. So we get natural log cosine of x plus, if you want, you can even rewrite that as tangent and make this a negative, minus x tangent x minus 1 over x plus 1, but then you have to multiply by y, because multiply both sides by y, so that you get cancellation there. What is y? Y is all of that. Cosine x is the x over x plus 1. Now, this is actually equivalent to what we have on the previous slide. Let's just compare. Here, if we take a look at this. All right, so let's take a look at maybe one term at a time. The term that has a natural log in it, like natural log cosine x to the x. Let's take a look at that. So if we were to multiply this to that term, notice we have a cosine x to the x, and then x plus 1 to the negative 1, or x plus 1 in the denominator. Does that look right? Let's just check it out. Was it this one? Yes, it's the exact same. So that term looks the same. So it checks off. All right, now let's take a look at another one. Which one should we do? Maybe the one that has a, hey, look, you see this term right here? This is cosine x to the x minus 1. Now, if we were to look at that, this looks like cosine x to the x, and then times cosine x to the negative 1, right? With properties of exponents with adding. Now, what is that times negative sine x think of this to the negative 1 power as being in a denominator. So negative sine x over cosine x, is that not negative tangent x? So we really have negative tangent x with a cosine x to the x and an x all over x plus 1. Let's take a look and compare what we have here. Okay, so this tangent, negative x and an x plus 1, it works out. This term actually gives us this one. This one's the same. Okay, now we only have one other term to check, which is this one right here. So if we were to pull out a cosine x over x, let's just compare and see. Okay, so right, when this part comes in and multiplies to this guy, you have the x plus 1 quantity squared, yes, in the denominator. That looks right. And then that, and then you have a negative 1. Let's just see, and you do have a negative. Yep, it all checks out. So really, as you distribute this and look at it, this is an equivalent result to this one. They are the exact same. Two different ways of getting to the exact same place. Both methods are viable and good and just fine. And that concludes this little video. Thanks for watching.